Hello class 8 students, welcome everyone. So in this video we'll be continuing the exercise question and answers. Okay, we'll start from question number 6 today. So let's begin. Here is the question number 6. A blacksmith hammers a hot piece of iron while making a tool. How does the force due to hammering affect the piece of iron? So first of all, when a blacksmith hammers a hot piece of iron, what type of force is exerting by the blacksmith? It is muscular force, right? It is muscular force. So a blacksmith uses his muscular force while hammering a hot piece of iron. So the muscular force changes the shape of the iron so that it can be given the desired shape. So how does the force due to hammering affect the piece of iron? Due to the muscular force exerted by the blacksmith will change the shape of the iron and it can be given any desired shape by the blacksmith. Clear? This is the answer of question number 6. Next question number 7. You see, an inflated balloon was pressed against a wall. An inflated balloon was pressed against a wall after it has been rubbed with a piece of synthetic cloth. It was found that the balloon sticks to the wall. What force might be responsible for the attraction between the balloon and the wall? Okay, now you see, you have understood the question, right? That there is an inflated balloon and first of all it was rubbed. The inflated balloon was rubbed by a synthetic cloth and then it was pressed against a wall. Okay, and it was found that the balloon sticks to the wall. Okay, so what type of force or what force might be responsible for the attraction between the balloon and the wall? What force is responsible here? It is electrostatic force. Okay, so here is the answer. When an inflated balloon rubbed with a piece of synthetic cloth, it becomes charged. Clear? By rubbing any material, the material will be charged. Okay, electrically charged. So when an inflated balloon rubbed with a piece of synthetic cloth, it becomes charged, and a charged body attracts an uncharged body. You know that, right? A charged body will attract an uncharged body and a charged body will repel a charged body. Okay, like charges repel each other and unlike charges attract each other. So a charged body attracts an uncharged body. In this case, the charged body is balloon, inflated balloon, because it was rubbed, right? A charged body is the inflated balloon because it was rubbed by a synthetic cloth. And an uncharged body is what? It is the wall. An uncharged body is the wall in this case. So a charged body attracts an uncharged body. That means the balloon will be attracted towards the wall. Okay, so when this charged balloon is pressed against a wall, it sticks to the wall. There will be attraction and thus the electrostatic force acts between the charged balloon and the wall. Clear? This is the answer of question number 7. You can pause the video and you can note it down the answers. Okay, I'll move to question number 8. Next question. Question number 8, you see, name the forces acting on a plastic bucket containing water held above the ground level in your hand. Discuss why the forces acting on the bucket do not bring a change in its state of motion. You have understood the question? You have to name the forces. See, you have to name the forces over here. Okay, forces, it has been mentioned here, forces. Clearly, it has been mentioned here what? Forces. Okay. Forces. It has been mentioned here what? Forces, yes. Okay. Not one force. There are maybe more than one force is applicable here. Okay, so that is why it is named as, that is why in the question it is mentioned that name the forces acting on a plastic bucket, and the plastic bucket is containing what? Water, and this bucket is held above the ground in our hand. We have to consider us in this question. Okay, so what could be the forces? See, there can be two forces here. There are two forces acting on the plastic bucket. One is the gravitational force. Okay, one is the gravitational force and the other is the muscular force. Okay, So for holding the bucket of water above the ground, we use muscular force, obviously. Clear? And this muscular force acts against the force of gravity that pulls the bucket towards the ground. Gravitational force is exerting everywhere in this earth. Okay, gravitational force is there, gravity is there in the earth. So gravitational force is acting where? It is acting downwards. Okay, and it is acting on all the objects present in the earth. Okay, including us also. So for holding the bucket of water above the ground, we use muscular force, and this muscular force acts against the force of gravity. Muscular force is acting where? It is acting against the force of gravity. Okay, why? Because you are holding the bucket of water, right? You are holding the bucket of water. You are holding the bucket of water, and the muscular force and the gravitational force is acting downwards. You are holding the bucket of water and you are trying to bring it up. Okay, so there the direction of the two forces are opposite to each other. Okay, this muscular force acts against the force of gravity. Gravitational force is acting downwards and muscular force is acting upwards. That is why it is written, this muscular force acts against the force of gravity that pulls the bucket towards the ground. Okay, because you are pulling, right? You are pulling the bucket of water upwards. So the two forces are equal in magnitude but opposite in direction. That is why there will be no change in its state of motion. Therefore the net force on the bucket is 0. Okay, the net force on the bucket is what? 0. Why? Because the two forces are equal in magnitude but opposite in direction, and therefore the net force on the bucket is 0, and there is no change in the state of motion of the plastic bucket. Clear? So this is the answer of question number 8. Let's move to the next question, question number 9. Here, a rocket has been fired upwards to launch a satellite in its orbit. Okay, a rocket has been fired upwards to launch a satellite in its orbit. Name the two forces acting on the rocket immediately after leaving the launching pad. Okay, again here the force of gravity is there, which is acting towards in the downward direction. Okay, the force of gravity is one which acts on the rocket to pull it towards the ground, right? Because the force of gravity acts in the downward direction. Remember, gravitational force acts in the downward direction. And the other force is what? And the other one is the force of friction due to the Earth's atmosphere, which opposes its motion. There will be friction between the force of friction between the air and the rocket. There will be force of friction between the air and the rocket, because the rocket will be fired towards the space, right? It will be fired upwards. So the air which is present in the atmosphere will exert a force of friction which will try to oppose its motion. Okay, so the two forces acting in this case is what? Force of gravity, that is gravitational force, and the force of friction. Okay, so this is the answer of question number 9. Let's move to the next question, question number 10. When we press the bulb of a dropper, you have seen a dropper, right? When we press the bulb of a dropper, you have seen the dropper. Okay, so when we press the bulb of a dropper, which is made up of rubber. Okay, the bulb of a dropper is made up of rubber with its nozzle kept in water. The mouth of the dropper is kept in water. Then what will happen? Air in the dropper is seen to escape in the form of bubbles. Okay, once we release the pressure on the bulb, water gets filled in the dropper. You have tried this, right? If you have a dropper with you, you can try it. If you press the bulb of the dropper, keeping its nozzle inside the water, then you will see that some of the air bubbles or bubbles will be formed. Okay, bubbles will be formed in the water. And once we release the pressure on the bulb of the dropper, then what will happen? Water will get filled in the dropper. Why it happens? The rise of water in the dropper is due to what? Pressure of earth, pressure of water, gravity of earth, shape of a rubber bulb, or atmospheric pressure. The answer is due to atmospheric pressure. There will be a rise in water inside the dropper. And what is the reason? You see, this is the reason. When we press the bulb of a dropper with its nozzle kept in water, air in the dropper is seen to escape in the form of bubbles. Okay, that means when we try to press the bulb of a dropper, that means when we try to press the rubber bulb of the dropper, then what will happen? The air in the dropper will be escaping in the form of bubbles. Okay, then we'll see the bubbles in water. Okay, keeping the nozzle kept in water. Okay, you have to keep the nozzle inside the water. So due to this, what happens? Air pressure inside the dropper is reduced because you are pressing it, right? You are pressing the dropper. That means you are excluding you are reducing the amount of air which is present inside the dropper. So the air pressure inside the dropper will get reduced. And when we release the pressure on the bulb, the much greater atmospheric pressure is acting on the surface of water. Atmospheric pressure is acting everywhere. In the surface of water it is acting. Okay. So the much greater atmospheric pressure is acting on the surface of water, then it will push the water inside the dropper. That is why the level of water will rise in the dropper when we release the pressure of rubber bulb of the dropper. Clear? So this is the answer of question number 10. You can pause the video and you can note it down.